Okay, so through your little activity there that had you play the role of a mathematician, you discovered a formula. Okay? You discovered that the law of sines is this set of proportions right here. I would go ahead and write this down in your notes, even though you did this on your discovery worksheet. I would hate for you to not be able to find the discovery worksheet when you're referencing your notes. Okay? The reason I asked you to do this activity is so that you could understand the trigonometry behind why this formula is the way that it is. Okay? So by using some altitudes and setting up some right triangle relationships, you went through the process of seeing how these three are indeed equal to each other. Okay? Now, when you go to use the law of sines formula, you're not going to use all three at the same time. Since we have three ratios that are equal to each other, you could choose a pair of ratios to set equal to each other for a proportion. But you'll never use all three at the exact same time. Okay? Choose a pair, set them equal to each other, based on the information that you have and the information that you're trying to get to. Okay? Now, what kind of triangle were you working with there? Who said that? An oblique triangle. Okay, if we have a right triangle, we have SOHCAHTOA, right? If we have a right triangle, there's no need for this. But what happens when we don't have a right triangle? Okay? The whole week is going to be spent on triangles that are not right. Okay? They're going to be oblique triangles. Okay? And the purpose of, and you don't need to write this down, but what I want you to understand is that we are going to be finding either the angles or the sides that make up this oblique triangle. Okay? We'll also see today opportunities for us to find the area of these oblique triangles without having to use 1/2 base times height. Okay? Now, when can you use the law of sines? There are only 3 instances in which you can use the law of sines on an oblique triangle. Angle, angle, side. So if you know 2 angles and a side that's not in between, you can use the law of sines. Law of sines. Sorry. Or, and here I'm just going to have to move this up, or angle, side, angle, which means you know 2 angles but the side in between. Okay? So I want you to think about the difference between these 2 scenarios. Angle, angle, side means we would know 2 angles and a side that's not in between, versus this guy, we know 2 angles and a side that's in between. It is not going to affect the way that we solve the problem, but I want you to understand the difference. Okay? Those are the types of problems you're going to see in your homework tonight. Okay? Your homework is going to be one of the more simple homework assignments that you'll have. Okay? Now, tomorrow, we are going to spend the day focusing on this scenario. So this is what we're going to do tomorrow. Side, side, angle. I'm hoping that the arrangement of those 3 letters stick out to you in a backwards way. It's a very special case. It's what we call the ambiguous case, and something very unique happens. So we're going to spend tomorrow morning talking about what is unique about the side-side angle scenario. Today we're going to keep it simple with our 2 angles and a side. Okay. We're only going to do one example because one example is all that we need. Okay. We are working with triangles. If you do not see a picture of a triangle, what do you think I'm going to ask you to do? I want you to draw a picture. It doesn't have to be accurate, but it is important for you to draw out the given information so you can decide if you have one of these scenarios, and that can tell you which method to use. By the end of Wednesday, we're going to have law of sines versus law of cosines. So it's going to be important that we have that picture so we can see what types of information we have. Okay, so go ahead and write down this set of given information, and then we'll draw us a picture. Okay. Okay, so draw a triangle and label A, B, C for your angles. Okay, and what we know that A is 32 degrees and B is 50 degrees, and that side C is 18.7 centimeters. Okay, so look at our triangle. We know two angles and we know the side in between. And so this is an angle, side, angle triangle. We know two angles and the side in between. And since it's an angle, side, angle triangle, we know that we could use the law of sines to figure out what the rest of the triangle is. Okay? So let's start with the easiest thing to calculate on here. We don't even need the law of sines yet for the first piece of information. We can find a third angle, no problem. We know that three angles of a triangle add up to be 180. So angle C, okay, angle C, so capital C is going to be 180 minus the other two angles, which gives us what? 98. And what's nice about that is we don't have to round or anything. We know that is exactly what it is. Okay? All right. So we know that angle C is 98 degrees. I'm going to label it on my triangle just so I have the visual. You don't have to. I will ask that you write your answers outside of the triangle in either circles or rectangles like I'm doing, so that my eyes, when I'm grading your work, you go straight to the answer. I'm not going to look in your triangle for the answer. Okay. All right, so now we need to figure out what side B and side A are. Does it matter which one we start with? It doesn't, okay? So let's just go in alphabetical order. Let's pick side A. So the law of sines formula, sine of the angle over the side equals sine of the angle over the side. So if I want to find side A, we're going to have to write the sine of angle A over side A. Okay? And which pair of angle side are we going to have to choose? We're going to have to choose C because we have both sets of information. So we know that the sine of 98 degrees is 18.7. Or over 18.7, sorry. How do we solve this? We cross multiply, okay? We can take A times the sine of 98 degrees and set it equal to 18.7 times the sine of 32 degrees. So in your calculator that is in degree mode, you would need to type in the 18 point, oh, in my 9-degree mode, I guess I should check that. 18.7 times, what did we say? Sine of 32. Everyone look at my calculator. If you're going to type this in all at once, do you see how when I press the sign button, it opens a parentheses? Mm-hmm. You better close it before you ask it to divide by, what are you dividing by? Sine of 98? So we have, for our side, 10.01. I did give you a label on the given side, so that label would also need to be on the side that we find. We now need to find side B. Okay. So we're going to take the sine of angle B over side B. Now here's where I'm going to be pretty picky, okay? Please don't work ahead of me. I want you to use as much given information as possible. Did we round our answer for 10.01 centimeters? Okay. I want you to avoid using rounded answers as much as possible, because if you use a rounded answer and then use it to calculate an answer that you then round again, you're going to start getting off by a decimal point or two. So instead of using a rounded answer, let's go back and once again choose the set of C's to set this equal to, and then we won't have any rounding errors. Okay, now you can continue calculating this, cross multiply. So you're taking 18.7 times the sine of 50 degrees and dividing it by the sine of 98 degrees. Anyone have something for me? This example always makes me giggle a little bit. When I was in high school, there was a boy band called 98 Degrees, and so it always makes me think of that. You guys have no idea who that even is anymore. But if you know the Backstreet Boys and NSYNC, it was during that era. See, you at least know what I'm talking about there, right? Yeah. Okay. So that's how old I am. And it's probably been before high school. Okay, any questions on the law of science? Okay, kind of a nice change of pace, right? We're still doing trig, but we're using our calculator. Okay, now, if you have the angle side scenario, your process is still going to be the same. You'll need to find the third angle and then from there set up your ratios. Okay, just keep in mind, use as much given information as possible, and what was I going to say? I had something else. Oh, be careful with that parentheses in your calculator. All right. I do want you to round to 2 decimal places, so just get used to that. Okay. Now, I know that you know that the area of a triangle is 1/2 base times height. Okay. But I want you to look at the triangle from your discovery sheet. You drew the altitude of K. That would be the height of your triangle. Would it take you some work to find the length of that altitude? It would take you a little bit of work. Sometimes it would be easier than other times, but it would take you some work. So, mathematicians developed a couple different ways to find the area of a triangle, without actually having to find the base and the height. Okay. Now we saw one way already. Do you remember back in our matrix chapter? If we had coordinates, we could figure out the area of a triangle with a matrix. Like we did the xy1, 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 and we did the determinant. Okay. Well, now, if you know side angle side, then you can use this formula. Now, I'll be very honest. You really would only have to write one of them down because the others are the same, just with a different set of sides and angle. But if you want to write all three of them down, you can. Okay? I'll let you write down the formula and description as you want, and then I'll talk about it some more. So if you know two sides and an angle, in between, that angle has to be in between those two sides, we can follow this formula to find the area. So instead of actually having to calculate the height of this triangle, we can take the two sides and multiply them by each other, multiplied by 1/2, and then you multiply by the sine of that angle that's in between the two sides. So this will always be the two sides as a product here and the sine of the angle in between those two sides. So whether it be BC and angle A, AB and angle C, AC and angle B, I don't want you to get hung up on which letters are which, but we are multiplying the two sides and then the angle is in between where we plug that into the sine. Okay, so 1/2 side times the sine of the angle in between. I have confidence that you can use this formula. For Friday, it's more of a matter of can you remember and apply it. Okay? If you have this open in your notes and you have a triangle with side angle side, really, is it going to be a difficult problem? No. But remembering the scenario, side angle side, and pulling up the formula from your brain, that's going to be more of what you'll need to focus on going into Friday. Okay. So, I have one example for you, if we're ready. I don't see any. Mary Kate, are you ready?
Yeah.
Okay. I didn't know if you were like doodling or writing something. All right, so write down this given information, please. Okay, so angle C is 102 degrees. Obviously, my triangle isn't even close to accurate, but I don't care. I just want a visual of where the sides and angles are. Okay, so angle C is 102 degrees. Side B is 52 meters, and side A is 90 meters. Okay, So look at that triangle. Notice how we have two sides that we know, and the angle that we know is in between. So this is what we call side, angle, side. Okay. Now, can we find the rest of the angles and sides using law of sines? No, we cannot. It's not one of our options. But for the area, we can use this formula. All right. If we know side, angle, side, we can take 1/2 times the product of the two sides times the sine of the angle that is in between the two sides. Thank you. Yep. You are a popular woman today. All right, when you punch this into your calculator, what do you get? And what would our label be? Square meters. Very good. And that's all your homework's going to be. A few triangles to solve and a few triangles